Okay, it's time to talk about rhombus and a parallelogram. So the first thing that we want to do is we want to get a definition. We're on bottom of page, or we're on the top of page 7, is where we're going to write our definitions. The definition of a rhombus is a quadrilateral with all sides congruent. So quadrilateral with all sides congruent. I think of a diamond, um, where your angles aren't necessarily 90, but all of your sides are congruent. That's what I think about with a rhombus. And a parallelogram is our other one. A parallelogram is exactly what would be a quadrilateral again, with exactly two sets of parallel sides. That would be a definition of a parallelogram. A quadrilateral with exactly two sets of parallel sides. So basically, in this first portion on page 7, they're going to give you a statement, and they're giving you some information about this rhombus, and they say, well, UV is congruent to VU, so basically we know that these are all indeed congruent, and if that is the case, then you have to make claims about angle UVW, so this angle. And I want you to think about that is if you had, say you have these two triangles, let's think about what this rhombus looks like. If I have this triangle right here, and I have this triangle, are the green and the blue going to be congruent? Well, you've got this side is congruent to this side. This side is congruent to this side, so we have side, and we have a reflexive, so we know the green and the blue triangles are going to be congruent. Well, if that's the case, then we know that this angle W is going to be congruent to this angle V, or VUX. I could split the rhombus the other way and color these two triangles and these two triangles and use the same proof. So basically, UVW would have to be congruent to its opposite angle, UXW. So that's why we can say that those opposite angles are congruent. Okay, so that is that's how those proofs that we've been working in the other ones. We're not going to do very many proofs with the rhombus or the rhombi and the parallelograms, but that's that thinking that helps you figure out whether when you don't remember all your properties. So that's what you're going to use on here, and then you have some things on parallelograms there. Now we have something called the parallelogram congruent parallel side theorem, and the words in it kind of tell you what it's about. It says, if one pair of opposite sides, so if one pair of opposite sides of a quadrilateral is both congruent and parallel, then we know it's a parallelogram. So, in this section down here at the bottom on page 7, it says, determine the missing statement needed to prove each quadrilateral is a parallelogram by this theorem. Well, according to the theorem, you got to have both parallel and congruent. So if we say we look at number 8 here, it tells you that MN is congruent to PQ. Well, if I want to show that this is a parallelogram, I need to know not only that they're congruent, but I also need to know that they are parallel. So I need to know that MN is parallel to PQ, or QP, and that's it. So that's how you do the bottom part of your page 7, and that is for rhombus and parallelogram. If you flip it over to page 8, in this section, I would like you to rewrite this proof that they gave you. They gave it to you in a paragraph form. I modeled this yesterday. I want you to put it into a T-chart. And I want you to figure out, what are they actually trying to prove here? Well, are they trying to prove diagonals are congruent? Are they trying to prove that opposite sides are congruent? Opposite angles are congruent? What are they trying to prove? So I want you to tell me that, and then go ahead and give me a T-chart. On number 12, I would like you to write down like number 1 of the square. That will help you. You're going to use that to model. And then number 13, you're going to do like number 3 of the square. So go ahead and circle 12 and 13, and then they've given you the proof. I want you to change it to a 2-column proof. So that takes care of the proof side. Those are the only 2 proofs that we're going to do for the whole thing, or for a rhombus and or a parallelogram, and you have examples that you can use for that. Then you have a couple applied problems, applying those properties. That's number 16, number 17, number 18, 19, and 20. And that takes care of this particular portion of rhombus and parallelogram. Now, if you go to, let's put some definitions in here. We've got rhombus. Oh, wrong one here. Actually, I'm just going to show this one rather than you having to wait for me to write it all. You can actually just pause the video right now and get this written down. But these are things that we know. Quadrilateral is 4 right a square. We already did square. Let's try this again. My bad. Rhombus. We have not done rhombus yet. So rhombus is a quadrilateral with all 4 sides congruent. So you can go ahead and make your markings. Pause the video and create that guy for yourself. And then you have 4 rhombus questions at the bottom that you're going to do. And that will take care of rhombus for you. And parallelogram, we'll flip to that one. And you can pause the video here. And you can go ahead and get that one in. We know that parallelogram, the parallel lines, the slopes are equal. That's something that's going to come in a little bit. I use these markings to show that these 2 angles are supplementary. That's not an official marking, but I wanted to somehow mark that the opposite angles are congruent and consecutive ones are supplementary. So if you notice, I have a green plus an orange. The green plus the orange is 180. They're consecutive. They're in a row. And they are supplementary. So if you want to pause the video now, make your markings, and then you can come back. Okay, you're back now. You're going to go ahead and take care of example 1, 2, and 3 on parallelograms. And that is rhombus and parallelogram.